All right, hey geometries, here's your key. And this was a great Unit 4 and 5 triangle review. If you're somebody that's hoping to take the retake of the Unit 4 test this week, this whole first couple sections were a great review for that. All right, so just passing through, we've got a right scalene. If they don't tell us we have any congruent corresponding parts, we can't assume it. So I know that this is an obtuse isosceles, an equiangular, and equilateral. Check out the sometimes, always, never section. An isosceles triangle is sometimes right, a right triangle is sometimes isosceles. That works both ways. An obtuse triangle will never be right, and a right triangle will never be equilateral. All right, these next two questions should seem familiar. I know you had them on your quizzes. So I started here with angle 3, figuring him out because he was supplementary with 58. Then, of course, I've got my vertical angles here. And then I used my triangle sum theorem to figure out the 36 and the 38 degree measures. I've got some complementary angles here, some vertical angles here. Triangle sum theorem gives me 60 and 60 and 60 and 60. And then, of course, I get that obtuse angle there. All right, this next section, I know that the sum of these three angles has to equal 180 degrees. So I went ahead and added up and solved for my x and then plugged back in. So I have a right scalene triangle. I found the sum of each of these angle measures. X had a value of 12. So I have an acute scalene triangle. Same thing here. I added up all of my expressions. And I ended up with x having a value of 20. So I have a right scalene triangle. Down here, when I solve for x and y, this is isosceles. So I set these two equal to each other and got a value of 22 for x. And then I went ahead and plugged in 22 for x. And then I had 2x plus 11s. And I was able to then solve for y. No problem. 2 was a little bit tricky because it was a system of equations. My first equation I wrote was 3x is equal to y plus x. And then my second equation that I wrote was 3x plus y plus x plus 90 is 180. So I had these two equations here when we simplify. So I go ahead and I solved a system. Here's how that looks. I did linear combination. My y's canceled out. And I ended up with x is equal to 15. And when I plugged 15 back into this equation, I was able to get y is equal to 38. Over here, again, I have an isosceles triangle. So I know that twice x minus 2, because this angle here is also x minus 2. Twice x minus 2 plus 4x plus 10, that's equal to 180. I was able to solve and get a value of 29 for x. And then I plug that in to this conversation here, 3y plus x minus 2. Here's my x minus 2 is equal to 180, and I get y has a value of 51. All right, on the back, hey, these should seem familiar to you. Check out your Unit 4 review. We went ahead and solved them, so that was good practice and a good memory for you. Here were your final answers. Go ahead back to your review packets and you can find the work, or you can go back and watch the video for the Unit 4 review for those. Hey, our triangle inequalities. Determine if a triangle can be given. I identify my largest side each time, and then I see whether the sum of my two smaller sides is bigger or not. Here, 6 is less than 7. That's why that's not a triangle. I went ahead and estimated the square root of 23 And then, of course, for pi, he's 3.14-ish, which puts me bigger than 13, so I'm okay. For this part, two sides of a triangle have these lengths. So when I set up my inequalities, x has to be bigger than their difference, and x has to be smaller than their sum. So I have this as my value for my x's. So when I find my perimeter, it's going to be the sum of each of those side lengths plus my two different x values. So 6 plus 11 is 17 plus 5 means it has to be bigger than 22, and 17 plus 17 means smaller than 34. All right, for angle B, my triangle sum theorem tells me 50 degrees. My shortest side is opposite my smallest angle, so that's going to be AC. My longest side is going to be opposite my largest angle, and that's going to be AB. For number 8, my largest angle, of course, is my right angle. My smallest angle is opposite my smallest side. When I write my inequalities about my measures of x, because 8 is congruent to 8, and this side is congruent to itself, I know that the larger side is going to be opposite the larger angle, so x has to be bigger than 9. This one's kind of cool. We want to take a look at this side, LM. LM is the largest side of this small triangle and the smallest side of this big triangle. So when I order my sides, that LM plays the middleman. He's the largest side of this triangle and then the smallest side of that triangle. All right, next up, more triangle inequalities. I know that the measure of angle J is smaller than K, and K is smaller than L. So because I know L is my largest angle, I know that this side here is my longest side, which means the sum of the other two have to be bigger than this other side here. So when I set up that inequality, 6x plus 4x is 10x. So 10x minus 20 has to be bigger than 2x plus 10. Subtract 2x from each side. 8x has to be bigger than 30. And x has to be bigger than 15/4. All right, when I'm looking at my hinge theorem, I have this side, it's congruent to this side's congruent to itself. So that means that because this angle here, if I have dr is bigger, or dr is smaller than nd, that means that nd is larger, which means angle 3 has to be bigger than angle 4. Here's my hinge theorem again. There's my included angle, and here's my included angle. This angle D is smaller, which means the distance from C to E has to be smaller. Hinge theorem again, between these two congruent sides and this side, because this is smaller, 1 has to be smaller. Hinge theorem again, because this is smaller, ET has to be smaller. All right, some Pythagorean theorems and the converses. So I know that my hypotenuse is my largest side. So I have c squared is equal to a squared plus b squared. So when I put those values through that formula, x is equal to 45. And yes, it's a triple because all of my values are whole values. This one's kind of tricky because I have two right triangles together. So my first right triangle, I have to solve for y. So 29 squared is equal to 21 squared plus y squared. So y has a value of 20. Once I know that, I can come down here and solve this triangle for x. Y is my hypotenuse. All right, when I'm looking at this bottom part, can they represent the lengths of the triangle? That means that the sum of these two has to be bigger than that. So when I look at 12 and 35 added together, of course, that's bigger than 37. When I put that through Pythagoras, they're equal, therefore it's a right triangle. So these are equal. Here's my largest side. 22 plus 25 is bigger than 40, so I'm okay. When I put that through the Pythagorean converse, I get this is larger, so it's an obtuse triangle. 17 plus 15 is not bigger than 32. Or 17 plus 15 is 32, which is not bigger than 34, therefore it's not a triangle. All right, so for this one, we have to use the distance formula. And if it's easier for you, now I don't know the orientation, but I do know that my triangle is P and Q and R. So first I figured out PQ, then I figured out the distance from P to R, then I figured out the distance from R to Q. So I got square root of 17, square root of 17, square root of 18. When I put that through the Pythagorean converse, I get an acute isosceles triangle. And that's my classification of that triangle. Oops. All right. Therefore. So my two congruent corresponding angles, because I was given that my triangles are congruent, I can look at corresponding parts and match up each of those congruencies. So we're moving into chapter 5 here, which is what you're going to see on the quest next class. So I know that these two triangles are congruent. Now the funny thing is they gave us so much information, any single one of these congruence postulates would work. Hey, be super careful on this one. These triangles are not congruent. True story, they're both equilateral, but there are no congruent sides. So there are no congruent sides across the triangles. These are all congruent, and these are all congruent, but there's nothing to say these two triangles are the same size. This triangle could be itty bitty bitty. All right, so those are my two right triangles that are congruent. Careful to match up YXW with YZW. I have these congruent triangles I was given, so then I can find those values by matching up corresponding sides. All right, so finally we're on this last page where we talk about congruent triangles. You know, some of these are very familiar, so be careful when you go through looking at each of those congruence postulates so that you can see whether or not you do or do not have enough information. I have no sides here, so this one can't be congruent. And then for our next section, more practice, proving those triangles are congruent and what we can use as a justification. All right, so our last section, section 5.3, talking about CP/CTC, corresponding parts of congruent triangles are congruent. So what's happening here is I can prove that the triangles are congruent through side angle side, but it's CP/CTC, what 3 additional pieces of information can I get? For number 6, I can prove the triangles are congruent, and then this is my additional information. Number 7, I can prove the triangles are congruent. Now this one's tricky because, and it's not angle addition, it's segment. My goodness. My segment addition tells me those are congruent. All right, so here's our two proofs. Are you ready? I'm given that these two sides are congruent, and I'll mark them in purple. I'm given that these two sides are congruent, and I'm being asked to prove these angles are congruent. So what I end up doing is using segment addition. First of all, I go from my congruent sides using my definition of congruence to having my measures be the same, because I'm going to be doing some substituting. And I'm taking a look at this triangle, and I'm taking a look at this triangle. If I can get those two triangles congruent, then those will be corresponding congruent parts. So I add my two congruent segments together by segment addition. And then I do some substituting to express RS in terms of RW. And then I can substitute again to keep them together, or I can use the transfer property of equality. They both work. So then I have my long sides of my triangles congruent. So don't forget I had my short sides here, and I just now proved my long sides. So if it's easier for you to draw these triangles, I have, this is triangle RST, and then I have this one, which we'll call RZW. These were the sides I was originally given. By segment addition postulate, I was able to get these sides. Because R is congruent to itself, I was able to get these. And then, of course, through CPC-TC, I was able to get my angles congruent. All right, so let's talk about this proof. I have my two congruent angle or triangles, and you might have missed that. This is what's given for this diagram. And then I can use CPC-TC to get the information I need to get back to that other angles using my corresponding angles, corresponding sides, vertical angles. I was able to get those two triangles congruent. All right, come to class with questions, and good luck.